Hello everyone, I'm your host Hassanul Banda Himel, Community Outreach Coordinator of AI, ML, Machine Learning, AI, Deep Learning, and MLP Community Bangladesh. So, welcome to our today's session, Introduction to Classification. Let me check if I am audible or not. Just give me a few moments. So, yeah, we're audible right now. So, welcome to our today's session. So, what are we going to talk about today? In today's session, we will be have some introductory. We will cover some introductory concepts on classification. We will see some essential maths for classification. We will see the logistic regression beyond, and we will see some coding problems. We will solve some coding problems. Thus, it will help us to grasp the knowledge of the classification. So, at first, let me share my screen with you. I hope that you can see my screen. So, what are the essential maths for this issue? If we write the essential maths, if we look at the essential maths, we will be having some views. At first, we will be having our probability and statistics. We will be then having our linear algebra, then we will be having some maths with calculus for our optimization, and then we will be having few more maths. We will be having uh, key functions and equation. And finally, we will be having our advanced maths. It will be just required for our complex models. If you have any questions, just comment down. I will answer your questions later on. So, what are the maths we will need for our probability and statistics? At first, for our probability and statistics, and statistics, we will be we will do some. We should have some maths, like we will be having our probability, our probability basics. In here, we will have some, let's say, we all have done the bias theorem. If you are new to the bias theorem or this probability or this math task, I have previously uploaded all the concepts priorly. You can check those videos or our communities again doing this math clubs so you can watch my fellow companions videos also. And then we have done the probability basics and we will be doing the Bernoulli distribution. Then we should need the conditional probability, and then the most common things like our mean, median, variance, and our SD or the standard deviation. It is mainly used for the feature normalization. And finally, for the probability and statistics, we all should know the probability density functions. So I won't cover all these math concepts as I have covered in my math clubs, or you can check our upcoming sessions for math clubs on our NLP community. I will go through some important functions in today's session, and then we will see a classification model. We will be building one on Google Colab, and we will see what are we going to really working on. This was our probability and statistics parts. Then in the second, we have seen the linear algebra. In this part, we all should know the vectors and matrices. One of the most important thing for learning machine learning and AI, or to dive deep in the world of deep learning. Then we should learn the dot product. We all know the dot product, how to get the dot product, or how one should determine the dot product of using these vectors and matrices. And finally, our matrix multiplication. Multiplication. So what are these mainly used? Vectors and matrices mainly used in, we use features, right? Features are represented as vectors, and also the models uses matrix operations. And then when we use the logistic regression, it uses mainly this function. Let me write it here. Z will be equal transpose X plus B. This is one of the function we use in the logistic regression, and we all know where we use the matrix multiplication used in optimizing classification models. Do let me know if you have issue in hearing my voice. I will improve that. Then if we move on, the calculus part, what is mainly required for our classification, or this calculus extremely sorry for that. It is mainly used for our optimization. Here we need the following things. We will be doing the derivative of sigmoid function. Today we will see the sigmoid function or how this works. Then how the what is or we should learn the gradient descent. Then we should learn the partial derivatives, and then finally we should learn the convex optimization. So this was our calculus parts. So it the sigmoid function is mainly used in logistic regression for the sigmoid activation. Our gradient descent minimizes the loss function using the derivatives, and in the partial derivatives, we update the weights in our logistic regression. So if we look at some key functions that equation, which I have here said earlier, we will be covering. If we look at, uh, let- yeah, here. So if we cover some key functions, we will be covering some key functions. Here we will be covering three functions. At first, it is the sigmoid function. The sigmoid function, it is mainly used, we will be today using in our logistic regression training, our logistic regression model. And then here, number two, we will be doing the binary cross entropy loss function, or also called as the cost function. And finally, we will be covering our gradient descent update rule. So these are some functions we will be discussing on today. And then we have some more advanced functions. We have in the advanced functions for advanced functions. If I am writing all of this, I should write this too. So if we look for the advanced functions for our, if we have the advanced function here, our advanced function, it is mainly these advanced functions are mainly used for the complex models. We have some complex models when you will be doing as a professional. There are some complex models. Here we use like the, you will be familiarized with the softmax function. It is mainly used for our multi-class classification in the logistic regression. Then you will be introduced with L2 regularization. And then finally for related to classification, we have another one. It is the Bayesian inference. Bayesian inference. Yeah. So our this L2 regularization avoids the outfitting by adding a penalty terms of which make our model more efficient. And for the Bayesian inference, it is used in probabilistic classifiers like naive Bayes. So this was our math part. Like these maths you should know, or these are the essential maths for learning our classification. Hey, Shomo, hope you are doing great today. Happy to see you in this session. If you came back, uh, these are the essential maths we need for our classification. We all should cover this probability. We should cover this probability and statistics, and then linear algebra, calculus, key functions, which we are going to watch today, and finally some advanced for if we want to progress in this line. So these are the maths, or these are the main maths we will be needing to solve these problems, or to do the classification problems properly. Now, if we break down like what is classification, or what is the math, or what is the purpose of classification. Like, let's say classification is one of the supervised learning which we use. Here, we all have seen that things, right? If I scroll down a bit here, uh, you have seen, we all use Gmail, right? We all use Gmail. Here, in the left hand side, there is a tiny thing called spam. Do you know how this spam folder classifies which one is like spam and which one is not spam, or which one is sent by some bot or some real people? Mainly, it classifies the mail in 0 or 1. Like if it is a spam, it will mark as 1, and it will put the spam mail into the spam folder. Or if it is a not spam, it will denote as 0, and it will show on your Gmail file, like in the Gmail location that let's say I have saying I sent a mail to my fellow classmates. He will see that if it was sent by a bot, it will be found in the spam folder. Like if we have some unsubscribed newsletter or something, sometimes we saw that in the spam. Or if I directly sent you some mail, it will be showing you in the your Gmail or in the direct mail. Thank you so much. So, also, it one of the example. Uh, let's say my Gmail is some easy example of classification, and then we have another example. Like, let's say we have a probability graph of, let's say, like, let me think for a bit. Let's say we have we have a bunch of people, we have their age, and we have that if they have diabetes or not. Okay, so we have two data. Let's say we have a bunch of ages, and thus they have diabetes or not. Let's say we have, like, I don't have diabetes, like you have my data, like I do this, and this is my age, and I don't have diabetes. And you have some of my friends' data, like some of them have diabetes and some of them don't have diabetes. So after the classification model, when we train the classification model, we can predict, like, it is not surely 100% that all the people of that age range should have diabetes or not. We can assume that, if I think, like, let's say on the perspective of our country Bangladesh, we think, let's say average after the age of 30, almost, let's assume I don't have the exact data, let's say 15%. 15% of the people got diabetes, right? So if I have, like, let's assume I have a data set that shows the most people above 30 or the 40s or in their 50s, they have diabetes. There's a vast data set, right? There will be a vast data set. There should be some people, those have diabetes, and some that don't have diabetes. So after we train the classification model, if I say like this is my age range, assume if this guy has diabetes or not. According to my data set that I have fed to my machine learning model, and according to my model's accuracy, it will show me that, let's say, if we think like after the ages of 30, 15% of the people will have diabetes. It will analyze it based on your age, your gender, your living place, your food habits, and other stuff. It will predict if either this guy have diabetes or not. So this is another kind of classification, right? We will classify either this guy has diabetes or not. Then we also do the image classification. I will be soon taking another session on image classification where we will be discussing on either how we can classify a image or either this is a dog or cat, the most easiest example. We will be doing a lot of fun stuff there. So how does these things work actually? As I said earlier, in the image classification, it identifies in either an image if it is a dog or either it is a cat. Either we can train another one, either it is a man or it is an woman. We all can do these things. So, what do you know about classification? Classification is a fundamental machine learning concept, widely covered in textbooks and research papers and online courses. We have some classification algorithms like logistic regression. We have our let me write down here. Let's say uh, here. So we have our logistic regression, and then we have our decision trees, our SVM, and finally in the neural networks. So that was some stuff you should know prior learning this classification or before you deep dive into the world of classification. So this was some few steps you should know before once you learn doing the classification. So if I move on, there's some another thing I forgot. Yeah. So where are we going to gain this knowledge? You should Many of you ask me in my DMs like what courses should you do or what things you should learn from. I'm not promoting anyone, but uh, things like I have learned from Andrew Ng's course. It is available in Coursera. Also, you can check the videos of Chris Nayak on YouTube and also the Three Blue and One Brown, his channel. They create some awesome contents. It will be helpful. It will be really helpful for you if you want to learn from the deep dive. And yeah, these are the few things. So now we will recall some things. Previously, we have told that we will be doing some maths, right? Here at first for this, I will be doing the sigmoid function or the activation function. So in logistic regression, we transform the linear equation, our linear equation, in the form of this into a probability using the sigmoid function. After using the sigmoid function, what will be our equation will look like? Uh, our sigmoid function, this is not, I had some mistake. Yeah, the sigmoid function of, let's say, z will be equal 1 over 1 plus e power minus z. So what does it do? It mainly converts any real numbers into a probability between our from 0 to 1. So if our we have some conditions here, let's say if our sigmoid function of z is greater than 0.5, we classify it as a 1, otherwise a class 0. It will be either a class 1 or class 0. So let's, if we do some maths in here, I was not going to do some maths, but it is needed for if you need the foundation for these equations. Let's say if our z is equal to 2, then our sigmoid of 2 will be 1 over 1 plus e to the power minus 2. If I do the math here, let me give some moments. It is giving 0.88. So as you can see, our this one is greater than 0.5, right? So we can say that this we can classify it as our class 1. So this is how it works in the sigmoid function. Now comes our some maths or more, which we will be also discussing on our code. And now we are going to discuss about, let me do some deep colors, our decision trees. I mean, decision boundary. So if we do the decision boundary or the decision boundary defined here for this one, it will be sigmoid of z, my bad, or sigmoid of z. Here the z is equal transpose of x plus b. Z is equal 0.5. So the solve for our z will be our we will have this w t transpose x plus b is equals to 0. This represents our linear boundary separating the two classes. We will be seeing in our code today. We will be doing some code examples. We will be dividing the most used code base today. And then what are we going to learn next? Here we will be covering the loss function here. If we do the loss function for, or also the binary cross entropy, here this helps to measure how well our model performs. So what is the equation? At first, I will write the equation and then I will explain which one is which one. Here, our L is equal minus 1 over n, summation over n, I equal 1. Here, our yi log of yi hat plus 1 minus yi log 1 minus yi hat. So this is my equation. So what is what? Here our yi is the true label either 0 or 1, and the yi hat is the predicted probability of what we have discussed earlier, sigmoid of wt x plus b, and our n is the total number of samples here. So why is this function? If the prediction is correct, we have some three test cases. If I write the cases here, at first our case one, if the prediction is correct, the loss is small. And then comes our case two. If the prediction, I will write just prediction is wrong, our loss will be large. Also, it ensures the model learns probabilities instead of just labels. And then we have our gradient descent, our gradient descent for our optimization. Here, our function will look like something like this. Minus alpha, function of L, W. Here, our alpha is the learning rate. Our del L over del W is the gradient of the loss function. For logistic regression, the derivative of the loss function will look something like this. It will look like 1 over n, summation n times I times 1 yi hat minus yi times xi. This means if the prediction of yi is too high, we decrease the w or the weight, or if the prediction of yi is too low, we increase the w. So this was the maths, or another one is important, like it will be the last part of the math, the confusion matrix. If we do the confusion matrix, also the performance matrices. Let's say, let me create a chart. This is for this is for that. Yeah, let's say we have here the actual or predicted. Here we have our class of 0, and here we have our class of 1. So, and also here our class of 0 and our class of 1. So here we will have our Tn or true negative, and here we will be having our Fp or false positive. here our fn or false negative, and here our TP or true positive. So from this, what we actually do, or like you will be like, why I should learn this? Like, what is the importance from for this? Like, why I should need this? I should memorize this chart or this table. From this, we can calculate the accuracy. We can calculate the accuracy. We all know the formula of accuracy, right? It is TP plus Tn over TP plus Tn plus Fp plus Fn. We can find the precision from here. We have our TP over our TP plus FP, or the true positive and false positive. Then we can also find the recall from here. We all know this TP plus Fn. And finally, we can do the F1 score. F1 score is 2 multiplied over precision multiplied by recall plus over same things, but in the addition. So this was the thing. This was the math parts, right? So what are the key takeaways from here? Some key takeaway, or why you should see or cover these things. Sigmoid function mainly converts your linear output into probability. Our decision boundaries where the probability will be equal to 0.5. Our binary cross entropy loss mainly measures the error. Our gradient descent optimizes the weights. And finally, our confusion matrix evaluates the performance. So this was the thing you should learn, or you should definitely learn if you want to dive deep into the world of machine learning. Now, here comes our another awaited part. Now we will see the code here. If we share my screen again, uh, yeah, it is a simple dataset. It is not some hectic or not some hard to understand. Here at first I have imported some libraries and then loaded the data set here. It is also commented for you guys if you want to see in which line which I am doing. Here I have selected the first two features for visualization, and here I have converted to the binary classification, and then I stated the data set, and then we did the feature scaling, and then we train the logistic regression model. If I, yeah, it will, and then we have did the predictions. If we run this, it won't show something. Let's see if we can understand something from here. Let's say our white bread. Now, if I run this you can see it is showing us the data, right? We have learned that it will give you data either in zero or the class zero or in the class one. We are getting our data in 1011, and then we are evaluating our model. We are looking for the accuracy and then coefficient and confusion matrix and then the report. If I, let's say, print these things, if I print the accuracy here and then our brain confusion matrix, and yeah, if we run this, yeah, this is our accuracy. Our we have done accurately, and then our confusion matrix are 10, 0, 0, and 20. And here is our report, like the precision, the recall, the F1 score, and the support. Also the accuracy, our macro average, and the weighted average. You all can find here. It is written also. Now for the visualization part, we will be visualizing using the matplotlib, and here finally our graph here. So you can see here we have done created a graph here where it shows either according to the sepal width and the sepal length which flowers goes under which one it does. Extremely sorry for that. Just give me a few moments. So here we can see here in the blue origin, the model predicts Setosa or our class 0. And in the orange origin, the model predicts the others or the class 1s. And the black border points, it actually the training data, which helps you to see if they fall in the correct region. So uh, I let me share my this file with you. Um, Let me share this. I am extremely sorry for the lag. So this was for our today's session. Thank you everyone for staying with us for this long period of time. I hope you enjoyed this session. If you have any questions, you can DM me or you can write into our community chat. So till then, stay happy, stay safe, and don't stop learning. Tata.